Hi class, this is Professor Bork. So I wanted to make a couple videos from chapter 9 because sometimes it can be rather challenging. So this question that I am recording is from the 9.1 homework. So everything in 9.1 is all about proportions, right? So in a lot of the questions, they have a sample proportion, and then you need to use that to create a confidence interval. And they have some new vocabulary. So for this question, number 13, it can sometimes be tricky because it's sort of the opposite of that. They give you the confidence interval and then they ask us to kind of work backwards from there. Okay, so it says determine the point estimate of the population proportion. Just so you know, whenever they say a point estimate, it sounds rather complicated, but it's really not. A point estimate for confidence intervals, if they're talking about, they refer to a point estimate, it's either the sample proportion or the sample mean. It's just sort of the point estimate is the word that they use to refer to either whatever the problem's about, proportions or means. It's the sample proportion or the sample mean. Okay. Then it also talks about the margin of error, which is just another fancy way of referring to the space from the sample proportion to the lower bound and the upper bound. And then it also asks for the number of individuals with the specified characteristic X. So they're like asking us to find X, and they're given N. Okay, so there's a lot going on here, and I just want to make sure we can kind of go through each piece and make sure it makes sense. So first things first, it says that the lower bound is 0.636 and the upper bound is 0.904. Okay, so what this means, they don't tell us really what the confidence level is, like 95% or 98% or whatever. It doesn't even really matter for this particular question. Okay, it's a proportion. So the sample proportion is going to be right in the middle. Okay, that is where we're going to, that's what they're asking us to find. Okay, so I have lost my pen for this morning, and I wanted to get this out. So bear with me. I'm using my mouse to try to write letters, and it never really goes well. Okay, so then it says the lower bound is 0.636. Okay, so again, we don't even really know like what we're talking about. Okay, there's no context given here. So we'll just go with it. Okay, so the lower bound is 0.636 and the upper bound is 0.904. Okay, so for some of these problems, I like to give myself a made up story, a made up context. It helps me. Okay, so let's say just for instance, that in terms of a percent, this would be like 63.6%, right? The lower bound 0.636 is like 63.6%, and 0.904, let's do that for that decimal as well. And let's say 90.4%. Okay, so let's just pretend, I don't know, we're talking about the number of people, the proportion of people who own a dog. Okay, so let's just pretend, I don't know, maybe we're 95% confidence that between 63.6% and 90.4% of the families in some area own a dog. Okay, again, I know it's just totally made up complex. It could be anything. It could be an approval rating for a president. All right, it could be the proportion of people who, I don't know, like roller coasters. It could be anything. It could be any proportion. And so sometimes it just sort of helps to give yourself a little made up context for some of these problems that are lacking that. However, not necessary. Okay, so the first part here says the point estimate of the population proportion is, okay, so again, it's just asking you in a different way. They really already found the confidence interval. Okay, the confidence interval is between 63%, 63.6% and 90.4%, or in decimal 0.636 to 0.904. Okay, they already found that. So this is just really kind of a way to make sure you sort of understand what's happening. Okay, so the point estimate of the population proportion. Remember, whenever they say point estimate, they're really just looking for this number here in the middle. They're looking for what was the original sample proportion, right, that we use to make that confidence interval. So there is a formula that's actually on the formula sheet that you can feel free to use to reference. It will be given to you as well on the on the next test. But just in case, like, it also hopefully intuitively makes sense that if we're looking for the sample proportion, that's just right in the middle of these two numbers, right? So in order to find the middle of two numbers, does it make sense that we can just add them up and then divide by 2, right? I hope that makes sense. And again, the actual formula sheet is going to have, and you can check those out on the formula sheet page that is attached with like the final exam information. So the formula that they actually give you for on that formula sheet would look like something like the point estimate equals, we'll say like the lower bound plus the upper bound, all divided by 2. Okay. So that's what that's going to look like. But again, hopefully it makes sense that really what they're just saying is that you're going to add the two numbers up and divide by 2 because it is just the number right in the middle. Okay. So I'm going to go ahead and do that in my calculator. It's 0.636 plus 0.904. I'm going to push enter and then I'm going to divide by 2. And it tells me that the middle number, which I probably could have figured out without the calculator, but you know why, would be 0.77. Okay, that would be the number directly in the middle, right? So again, just kind of making some, like adding some pretend context to the situation. Let's say we started out, right? We surveyed 1,000 people and we found that 77% of those people owned a dog, right? Or whatever it is, that's where we would have begun. And that's why this problem can be sometimes tricky because it's the reverse. All right, the next problem says the margin of error. So hopefully, again, this is just another way to make sure you understand what margin of error means. So margin of error is just the distance from that sample proportion out here to the upper bound, and then also same in the other direction, the subtraction version of the margin of error. Okay, so this would be like E sometimes is what they refer to it as. So whatever you had for your sample proportion, which was 0.77, you find the margin of error if you were finding this by hand, and you would add it to get the upper bound, and you could subtract it to get the lower bound. But they already did all that for us. Okay, so again, this is another one of those that intuitively you could figure out, or also if you prefer, there is the formula that is on the formula sheet. Okay, so the margin of error for this problem, hopefully it makes sense. It's just going to be, they think of it as a formula. You could take the upper bound minus the lower bound. Okay, so you figure out like how far that distance is from all the way to the left, all the way to the right, and divide it by 2. Okay, there's a few different ways you could really kind of come about this formula. You could also just say like 0.904 minus 0.77, right? Or you could take 0.77 minus 0.636. That would all get you the same thing. Or you could use, again, the formula where you subtract 0.904, take away 0.636, you push enter, and then you divide by 2. And this is the margin of error is 0.134. Okay, so hopefully that makes sense. Again, these questions are always challenging because they're the reverse of everything that we've been doing so far, where they give you a sample proportion, maybe a sample size or whatever, and you need to use stat crunch to find the confidence interval. The confidence interval is already here; it's already given to us, so we have to just kind of work backwards and use the formulas or just like intuition to figure these out, whichever works best for you. Okay, the last one can sometimes throw people for a loop as well. It says the number of individuals in the sample with the specified characteristic is blank. Okay, so for this particular one, they told us, right, that the number of people that they sampled, n equals 1,000, right? And we also know that the sample proportion, we calculated that was 0.71. Okay, so we really just need to calculate. There were some questions that are kind of similar to this in 8.2 about like tattoos or students who go to ACC or take classes online. If we know the sample is 1,000 people and we know the proportion of that sample, oops, sorry, I wrote 0.71 instead of 0.77 is 0.77, right? Like, does it make sense that we just need to find what like the 77% of 1,000 is, right? We can just multiply 1,000 by 0.77, right? Does that make sense? And so for this particular last question here that they want us to fill in, 0.77 times 1,000 would be 770. Okay, so I hope that made sense. Again, that was question number 13, which can pose some problems because of how it's sort of like the reverse and it throws people off. There's not a lot of context given to these problems. So when that happens in these last few sections, I sometimes just like to make up a problem in my head that kind of matches it. And it often revolves around owning a dog. I don't know why. You can make up whatever it is that you want. You can, it can be about approval ratings for our county executive. It could be people who like to take online classes. It could be anything. Okay. I just, for some reason, like to talk about people who own dogs. I don't know why. Just make it up. Okay. Thank you, class. Keep me posted. Whatever help I can help with, because I know chapter 9 and 10 really can be a lot. Chapter 11 is really, as long as we have 9 and 10 down, 11 is just like really the same thing as 9 and 10, just with 2. And the ideas are all the exact same. It's just a slightly different button in StatCrunch, really is all it's going to be happening there. So please make sure you let me know whatever questions you have about chapter 9, because chapter 10 is similar and so is chapter 11. Okay, thanks, class.